What if I told you that you can build a fully functional Flutter app without writing a single line of code? Sounds crazy, right? But today, I'm going to show you how I build a weather forecasting app using Cursor AI without actually coding it myself. Of course, I will also ensure that we apply clean coding principles with my own style to keep the project maintainable and scalable. If that sounds exciting, make sure to stick around. If you love AI-driven development and want more vibe coding sessions, hit that like and subscribe button. Let's dive in. Today we are going to use Cursor AI. It's an AI code editor. You can download it from this link. I'm going to share the link in the description. And also we are going to use Super Whisper to speak to the AI with our voice. Let's talk about what we are going to implement. We are going to implement a single page, a page where we display the weather forecast for a city. We have a city selector, we have an icon that represents the weather, city name, selected city name, the temperature, the unit of the temperature, whether it is sunny, cloudy, rainy, etc. And also a button that the user can use to switch between Celsius and Fahrenheit. Finally, we have humidity and wind data. Now that we are familiar with what we are going to build, how should we start implementing this feature? Usually, if I just ask AI to build this right away, it builds me something that is working, that is true, but usually it builds it in a way that I don't want it. It becomes usually hard to maintain. Instead, what I'm going to do is to ensure that AI writes code that I can maintain, read, and understand. The first step I would take is to ensure that I have the proper rules provided to Cursor. These are the rules that the AI will follow when writing your code. In these files, I specifically define what folder structure I use, what naming conventions I prefer, and for each layer, what are my preferences. Let's talk briefly about the directory structure. In my projects, I usually keep my features on the lib, and each feature holds their own layers. Each feature holds 4 different layers: application, domain, infrastructure, and presentation. We will talk about them in detail soon, so don't worry. Here I define naming conventions, code organization, how I store my constants, my widget structure, everything what I want AI to know. I won't go too much into details to not bore you. You can read them yourselves. I will share the GitHub link in the description of the video. Let's start with something fun first. I want the AI to implement this UI page first, and then we will talk about how can we make this implementation maintainable and scalable. I open Composer using Command L. I select this. We are going to use agent mode. You can switch between normal mode and agent mode. Agent mode is the mode where AI writes the code for you. Now, what I'm going to do is to select this design, this PNG file. I will put it here. I'll speak to the AI directly. I want you to build this page, but I want you to build this page using my Cursor rules. Just create this page only write the UI code. For the values, use fixed values for now. Ensure that you follow my rules for folder structure and writing widget code. Don't do anything else. It made some changes. It removed this text weather app and created a page called weather page. And this page contains all the things we need. Let's see how it looks, and then we can iterate over it. I save this, reload. Let's see what's going to happen. Okay, I think it is pretty good. The design looked like this. It is not exactly the same, but we are not too far. I think with going back and forth a few times, we can make this perfect. But I'm not going to try to make this perfect for now. I want to focus on maintainability and scalability of the feature more in this video. I realized that it created a folder called features, and below that it puts weather, presentation, pages. In the document I provided, I put my features right below the lib, but it created something like this. We can ask it to fix it anytime. I want you to move the weather feature right below lib. I realize that you created a new folder called features. I don't want that. Let's wait. It's not now going to delete all files it generated and make the migration. Okay, as you see, it created this weather folder, but the weather folder only has the weather page. I want it to be like weather, presentation, and weather page. I want that hierarchy. Let's ask it from the AI. I realized that you put the weather page right below the weather. I think you should put it below presentation layer. I'll accept the change, accept it all. What happened now? Yes, we have weather presentation. Under presentation, we have weather page as we wanted. Now I'm going to delete this old folder to keep it clean. I accepted all the changes coming from the AI. Oh, this is an old change. All right, now we have some UI to begin with. I think we are in a good state. We still haven't written any single line of code, but we have a UI that works. As a second step, I would start writing code in the domain layer. Domain layer is the part where we define our interfaces, our data models. This is the part where we should start from. The reason is it is the part that is the most independent, so it doesn't depend on any other layers. If we start from here, then the AI is less likely to hallucinate. Let's dive in. Now I'm going to open a new composer. I recommend you to open new composers frequently. It is going to benefit you a lot. AI will give you better results if you keep their context short. Let's continue with the domain layer. Before asking AI to do anything, let's decide on what we want. For this, I think we want some kind of data model. We need a weather model, something like that. The weather model will contain the following properties. Let's jump here. We have the city name, we have the temperature, whether it is sunny, humidity, wind, etc. We want to keep all of these information in a model. When I am writing my data models, I usually use freeze. This way I create immutable data models, and it comes with copy with method automatically, and it has value equality checks as well. I think it makes sense to write a data model for weather. You can call it something like weather model. This model should keep these properties that you currently hard code. I want you to start writing the domain layer. In the domain layer, I want to have a data model for this feature. You can call it weather model, something like that. Read the rules files that I provided to you for naming conventions and use the conventions from there. Do not generate anything else, only generate the weather model. Now it is checking the rule files that I provided. Okay, it made the generation. We go to here, we see a weather model that is implemented with freeze. It even have some default values for each field. That's great as well. We have city name, temperature is Fahrenheit, condition, humidity, wind speed. Perfect. It has simply everything we need. Now it is asking us to run the build runner so that we can generate code for freeze. It wants confirmation from us. Run the build runner. I don't write any terminal commands. I just say run the build runner to the AI and it runs it. We generated our files. Now I'm going to accept this file. And currently we have a data model and a UI page. What is next? I think we should receive this weather data from some source. It could be from mock data. It could be from an API. For this, I usually create an abstraction. We can create something like iWeather service. Let's ask AI to do that. I want you to create some service to get this weather data, but only create the interface for now. Don't create anything else. It usually creates some other stuff that you need to clean later on. Sometimes it forgets about the rules and creates its own stuff that doesn't fit your own coding conventions. Here we have an interface called iWeather service. It has two different methods. Get weather for city and get weather for current location. That's actually handy. Both of these could be useful. And we have an enum that defines the possible errors. It could be network error, city not found, server, an unknown error. These are all the cases that we can have when we have a network request. So that makes sense. And we have well-documented code here. We provide city name and we get some weather model. So everything looks perfect. We use a custom return type called results. This is what I usually use, but I don't think that we have added it currently. And also realize that we currently don't use named parameters. I want to use named parameters instead of using it like this. So let's ask these changes from the AI. I want you to use named parameters always, so fix that. And also I see that we have an error on the return type result. I think you should add the dependency. I'm only approving what it is suggesting to me. I do nothing else. Now I have the result. We have a problem with this exception here. It says whether error doesn't conform to the bound of exception. I think it should be a type of an exception. It should at least extend exception. I will not think of any solutions. I will just AI to fix this. I give the context first. I'll say use this context so that it sees what page we are working on. And I will say this. We currently have an error. Would you fix that? It is something about the weather error enum that you created. Okay, it fixed the problem with creating another class called weather exception that implements exception so that we get rid of the problem. And this weather exception does have a type with this enum. It looks like a good solution to me. I will just accept it. Even if it doesn't work out, I'm not the one that's going to write the code, so AI can come back and fix this. So currently we have an interface, we have data model, we have UI. I think we should get this data from somewhere. The next layer I'm going to implement is the infrastructure layer. It is the part that is going to implement this interface that we defined here. So let's begin. I think we can start with implementing the data transfer object first. That is going to serialize and deserialize this weather model. And then we are going to ask it to implement this iWeather service. Initially, I'm going to return only some mock data, but then we are going to replace it with some real data source. Now we are implementing the infrastructure layer. Create the data transfer object. How you should create it is defined in your rules file. Please read it and create a data transfer object accordingly. Don't create anything else. It created something. We have a DTO here. It also defines some JSON keys. I don't know if we are going to use these keys exactly in the future, but we can modify them depending on which API we are going to use. We may modify them. We also have to-domain methods to convert DTOs to our domain models. That will be also handy in the future. I think we should generate the code now for freeze. I want you to run the build runner and generate code for freeze. It first needs to add to the JSON serializable. Sounds good. It also wants to add JSON annotation. Okay, writing code is not my business. I only give comments to the AI and it writes it. Perfect. Now we have this generated, but I think we have some errors. I realized that we can't have this to-domain method, I guess. So I will ask it to add it as an extension method. I realized that there is an error in freeze file of weather DTO about to-domain method. Would you make it an extension method? This way we are going to get rid of our problems in code generation. Run the build runner again. And we got rid of all the errors. Now let's create the service. I want you to create the weather service implementation. You are going to implement the iWeather service interface that you previously defined. For now, just use some mock data to return from there. Don't use any real implementation. Right? We have some implementation here. We implemented get weather for city and get weather for current location methods. Both of them are returning success or failure. Okay, we are returning some mock data model for now as we requested. Perfect. Now we completed the infrastructure layer as well. We have domain, infrastructure, presentation, and finally we are going to implement the application layer, which is our business logic layer. This is the final layer we are going to implement. Then we are going to get everything together and have a clean code. Now let's ask it to write our qubits. I want you to start writing the application layer. In the application layer, follow the rules that I provided to you and implement my qubits. Use this iWeather service we have just implemented to get the data. Now let's move forward with the application layer. I provided all the things needed in the state management.mcd file. Please follow them and write weather qubit. Okay, it's asking to add Flutter block and it has generated some files that I don't want for right now, but we are going to ask it to fix soon. It wants code generation. Do it. Let's get rid of the errors. Now it's done. I realized that it created some data state underscore. It is weird. It shouldn't have done that. We already have a data state defined here like this. It should have used it. And below application layer, we have weather qubits. It looks good. And we have weather state. We are not too far from what we want, but we will ask for some small changes. I realized that you created a new data state class underscore under application layer. We don't need that because we already have a data state.dart class underscore. please use that. Accept the deleting of the file. It starts generating code. Let's get rid of this redundant file and folder. Now that we don't have any errors, let's review the code. I will just accept the file. We have a weather state. In this weather state, we have a data state of weather data. We are going to get this weather data from a remote data source, and this remote data source will respond to us with some delay. So we will be in is loading state for a while, and after that we will be either in success state or a failure state, and initially we will be in the idle state. It also defines an initial state like this, and in the state we have only weather data and last search city. And in the qubit we are getting iWeather service from the constructor. The implementation looks good. It is also testable. In the upcoming videos I will also show you how you can use Cursor AI to write widget tests, UI tests, or qubit tests. AI is really good at writing tests. We have two methods, get weather for city. We get a city name from the UI, and then we go into in progress state and we put the city name into state. We make the service call with the city name and it comes with a result. If the result is success, we emit success state. If it is failure, we emit failure state, and that's it. It also provided another method called get weather for current location. I don't know if you will use this, but it could be useful depending on what your goals are, and it works quite similarly. Now we have all the layers we need for this service in a very clean way. It's perfectly clean, well structured, maintainable. Now the only thing that we need to do is to integrate this application layer, this qubit, to the UI, and then we will be getting everything from the infrastructure layer. Let's do that. I want you to depend on the weather qubits for the data that you show on the UI rather than putting hard-coded values. We are getting some errors, but don't worry, we will get rid of them. Now it's done with the generation. We have a block provider added here. It creates weather qubits, it provides weather service, and it calls the initialize method, get weather for city method for New York. So it's one-to-one matching that. It also provided all the other methods here. It added block builders. Everything looks right to me. Maybe reloading the app will solve the problem. I don't know. Let's see. I don't think the issue is going away. Let's see what the issue says to us. Data state loading. Implementation has no instance. Getter is loading. I will not try to debug the issue myself first. I will let the AI think first. It is applying some fixes now. Let's try if it's going to solve the issue. Reload. Nope, it didn't solve. We might need to intervene. Let's see what's going on. We have weather. I don't exactly know why the issue happens. I realized that when we try to access this is loading, has failure, is success fields, these look dynamic and it shouldn't look dynamic. I will ask this to AI and try to fix this. Maybe the problem is in this data state class that we have. The data state class has some extension Boolean getters. I don't think that you can access to them properly right now. This is why we are having errors. Do you know any fix for this issue? Let's see. It made some changes and we got rid of the error, but now we are only seeing the loading indicator, which is weird. I reloaded and the issue went away. Okay, we don't have the red screen now. Everything looks fine. Now also implement this switch to Celsius method. Let's ask AI to do that as well. I want you to implement switch to Celsius and Fahrenheit button in the UI. I want you to add a new method to weather qubit for this and connect it to the UI. Let's see. Okay, it generated some new methods called toggle temperature unit. It is converting what we have in the state between Fahrenheit to Celsius simply. I will directly test it in the UI. 73, 23, it looks right to me. Perfect. So we added another feature here. On the UI, it changes as well. Everything looks right, so I'm just going to accept. Things look right now to me. As a final step, I'm going to connect this UI to a real data source so that we get real data from the backend. Okay, now I'm going to use a service called openweathermap.org. You can create your own account and get a API key that you can trial with. I get my own and I will use that. Please follow the steps shown in the documentation of this website. I want to use Open Weather Maps API to get the data. Please use this in the infrastructure layer in the service implementation, and I want to show the real data using that. I think the only thing that you need to change is to use this implementation in the infrastructure layer, and everything should work. It wants to add HTTP. Okay, let's add. It created some sort of constants file. We're going to put our own API key there. Now it is also updating the DTOs because the JSON field names probably don't match. Let's generate code. Okay, it's done now. Now I'm going to put my own API key here so that it works without a problem. Let's see what happened now. We see some sort of error on the screen. Let's first accept the changes. We have some changes in the DTO. We have new field names. We have new DTOs, weather main DTO, weather condition DTO, wind DTO. We now have a more complex model, but we still haven't changed this main weather model we use. That's good. Okay, what is wrong? Let's reload the app and see if it's still solved. Oh, we have some exception. Weather exception, server something. Let's try to figure it out. We're currently getting server error 401. Do you know the reason? I guess I put some invalid API key. After debugging for some time, I figured out the issue. It was an issue about my API key. I guess I forgot to confirm my email address. So right now everything looks pretty good. Now that I can see city name, temperature, I guess it is clear weather in New York right now. We are getting it from real data source. This is real time. Let's actually experiment with more city names. I will try it with Istanbul. Let's see what's gonna happen. Really nothing happened. Why? Oh, because we have some issues here. Let's ask what's wrong here to cursor. It's probably a widget hierarchy thing. Okay, let's see if it works. And it worked. I typed Istanbul here and I get the weather for Istanbul. It is cloudy. It is -1. It is cold as fuck right now. We're freezing. Let's search Barcelona. No, Barcelona is good. It is 14 degrees. We can see humidity data, wind data. We can see everything right now with the real data that comes from the API. I think that makes it for the scope of this video. I want you to give attention to one thing. In the beginning of our project, we had some design like this, and we had a selector that we can select different cities from. But later, as we asked AI to iterate on the project, it converted this selector into a search bar, which is something that we didn't ask. Sometimes AI hallucinates and makes this kind of mistakes. So whenever you are writing code with AI, you always have to follow what is exactly doing. I am not going to spend a lot of time to make this UI pixel perfect. When you are working on real projects, you have your Figma designs and you can use this Figma designs to build this pixel perfect. The goal of this project was to show you that you can use AI to write code without actually writing code, and you can have this code in a way that is scalable and maintainable in a clean way. That's it for this video. If you want to see more vibe coding videos, more vibe coding sessions, like the video and share your comments with me. See you in the upcoming video. Bye.